Okay, hello students. Here I'm making another video, and this is a continuation of problems from quiz number 7. The last video I did 1 through 6. So today I'm gonna continue with 7. And this problem is really nice and to understand why do we even have to learn? Why do have we have to learn? to to le- to learn rational function. What's the importance of this rational function, and how can we model real world application problems? Now you see there is a problem number 7 says that a game commission introduces 100 deer. So there is a population deer in the beginning. 100 deers are being put in the game, not I mean in the acquired state game land. So on the land, so there are in the beginning you have 100 years. So in the beginning the land is so for this we can straight away even draw the graph for this part. So it starts from 100. So I'm going to mark also that in the beginning the deer population was where the hell? Okay, here it is. Oh, okay. So the deer population, let's put it like this. There's 100. I'm just making this as 100. So now, then this equation, what does n represents? This n represents the deer population, n of t. Since what is t stands for is the number of years since in the beginning there was 100. So the population is growing of the deer population, and nt represents it. So this equation represents that. So whatever that. Now to check whether if you put t equals 0 in the equation, that if I put this is 20 times 5 plus 3 times 0, and then you see 1 plus 0.04 times 0. So this whole thing becomes 0. This will become 0. What I left with only 20 times 5 divided by 1, and it is 100. So we are right. So that means this model is really works for deer population when in the beginning it was 100. Then as the years pass by, the deer population maybe in the beginning, we don't know. Let's see how the graph will look like. Okay, what do we have to know here is what is the vertical asymptote. So we need to know what is the vertical asymptote here, and you can see the vertical asymptote. You need to know the graph of this, right? The question is how the graph look like. So if you check to know the vertical asymptote, you divide. Let's clean this off. So the first step is what is the vertical asymptote. Next is the horizontal asymptote, and the next is what is the x-intercept and the y-intercept. So the vertical asymptote here is you put the denominator equal to 0, and when you put the denominator equal to 1 plus 0.04 t equals 0, and then you subtract 1 both sides, you get 0.042 equals minus 1, and then divide by 0.04 and divide by 0.04. So this goes out and you get t equals, and there's a multiplying 100 both sides here. So you multiply 100 to get away with the decimal in the denominator. So you get minus 100 over 4, and then that becomes minus 20. So the first question is, how does the graph look like? So we need to know what is the graph, and so let's do. So we know the vertical asymptote is 20. So somewhere here, maybe here, somewhere here, and I'll draw a dotted line here. That's the vertical asymptote. And now our graph has to go down here as you go closer to this minus 20, then the graph will go, and then it has to go to 100. So it has to go 100. So let's see. So the graph has to go 100. But the question is, how does what it looks like after that? And for that, we have to know what is the horizontal asymptote. So for this, let me clean this quickly. Uh, okay. So now, so to find the God, to find the horizontal asymptote, uh, then all we need to know is what's the degree. So the degree at the top, this can be written as same as writing 20 times 5 and 20 times this will be 100 plus 60t, and the denominator is 1 plus 0.04t. So you can see the degree for both numerator and the denominator is 1. So the vertical asymptote will be y equals the ratio of the coefficient p of the leading term in the numerator divided by the coefficient of the leading term in the denominator. So that is 60 divided by 0.04, and we can get away with the, okay, let me write it here, 60 0.04. So you multiply 100 up, multiply 100 down, so that becomes this decimal. Oh, sorry, this is not, this is just a 60. So it is 60 times is 6,000, and divide by, you get, the decimal will move two places because of these two zeros, and you get 4, and this becomes half of 15, 60, quarter of this is 15, so you get 1,500. So that's the horizontal asymptote. That means there is a horizontal asymptote. Let me graph it. So this, let me use some different color. So this is how the horizontal asymptote, which is y is 1,500. What it means is the population starts at 100, and eventually you can see, because it is a horizon, as this goes on increasing, as the years goes on increasing very large, so as goes on become very large number, many years, 10 years, 20 years, 30 years, 100 years. So what the population of the deer will be, the behavior of the population, deer population, almost goes closer to, so this number, which is 1500. So even though this 100 doesn't, the y-axis doesn't exactly do the justice, but understanding is this is how the population will look. It starts from here, and then almost it reaches the 1500. So the question could be asked is, what are the, it could be asked, find the population. So quick question could be put here is, what is the population when after maybe 10 years, or I'll just put easy question, or 8 years. So what is the population if it is t is maybe 9, or t is 14, or t is 19? All we need to do is, you can use the calculator, but not the graph. You're not supposed to graph and show this. So let me take directly to the Desmos, NSPY calculator. Go here, click on the calculator, and then because that NT, I'm putting that the the function. So how do we function is, I'll put N and then T. So let me use directly a new one so that we don't mix up with the old one. And then I want to use the calculator and type in NT equals. So what was that? I forgot. So it was, let me check. So 100 plus 60t over 1 plus 0.042. So there is this numerator, denominator. Now I have to save this. So what all you do is click on the control, and here, so you have that colon and equal sign, and then you write up, down, and for that you have to have numerator quotient. So the top is 100 plus 60t, so that's 100 plus 60t, and the denominator was 1 plus 0.00 over n t. Okay, so let's and say enter. So done. Now all you do is, suppose they ask you for 9 years, so you just type in n, open parenthesis, and put 9, and you get answer. So that's like almost 617 deer population after 9 years, or if you put maybe 18 years, so you'll get the answer as this one. See, and we put, and if I put 40, just, and the population 2,100. So the population goes on increasing. So now the question is, remember, we can't have population 2,100 because our maximum is it has to be 1,500. I think I typed, if you see here, I typed the equation wrong. Let me go get back there and change that. And this should be 0.04, and that's the mistake I did. So now I'll have to do everything change. Sorry about that. So this one is n, and you put maybe 9. I think I put 9, and that's like 470. And n of 18 will be use 686 and n and 40. So look at this, and you get 961. And if I put n of 100, just wanted to see what's the answer, and it gives 1,200. See, it never goes beyond 1,500. Let's put 150. Let's see. See what happened is you almost get 1,300. And if I put a bigger number, of course, this is 200 years is too much. How can it's like 1,344? Just for to check on the inquiry-based learning as what would happen if it is 1,000, let's say 1,000 years, and it's like almost 1,465. If I put another zero, maybe I don't know, and I put 10,000, you see, almost like 1,500. So that's an idea. Is the herd population can never cross 1,500. That's why there is a horizontal asymptote. Here it is. That's why there is a horizontal asymptote here. 1,000. So y is 1,500. It never crosses the 1,000 threshold of 1,500. Hope that helps. Let's move on to the next question. So it says f is already 1 function, and it takes the pre-image of 8. So 8 goes to 19, right? What does f do is it takes f takes 8 for the input to 19. In other words, you go back, that becomes f inverse. So the new function, which is the inverse function, takes the output. So this is the output, which is the range becomes the domain, that is 19 goes back to 18. It means if 8 and 19 is a point on the graph of the f, then 19 and 8 become the point on the graph of f inverse. Same thing is the other one you can do. Let's go to the next. So you can see there's a graph of this. This is the graph of G, and they're asking what is G inverse of 3. So imagine you don't know what is the answer. I'll just put it like a P. Well, all this means it is G of P is 3. So they already give us the function G, and it says 3. This is the output, which is the Y, and this is the, we want to know what is X. So 3 will be, if this is 1, 2, and 3, that's the 3. So then you just go all the way, right? Touch, you can see this, that's the point, and then go all the way down, and that is 2. That means, all that means this is G of 2 is 3. That means this is 3, and you're done. So this is the answer. So if they ask you this, then you go 4, and you just go here, and if you get the answer, what is G inverse of 8? So all the way 4, 5, 6, 7, 8. That's 8. So you go all the way here, and you can see that is, this is 4, 5, 6, 7, 8, and you're done. So question number 10 is find the inverse. So they already gave us this. All you do put is replace f of x by y first and write y equals 8 of x over x minus 5. Then replace x and y by, so y is replaced by x and x is replaced by y, and then you solve for y. So all you do is, this is 1 multiply, use the cross product. So when you multiply, you get xy minus 5x equals 8y. Then you need to have all the y's on the left side, so subtract 8y. I'll put it below here. And at the same time, add 5x both the side. And when you do this, you'll see this goes away, and this becomes x minus, sorry, xy minus 8y. This crosses out, and you get 5x. And then divide by, and you can see there's a y which multiplies, so we can pull out y outside and write x minus 8 using the undo distributive property, and then you divide by x minus 8 and you get the answer. So this will cross out and get y is 5x upon x minus 8. In other words, the inverse function is 5x over x minus 8. And you are done. So you need to show these steps are important. Now to sketch this graph inverse function, so all they gave us is the this is the f function, that is f of x, and you need to sketch the. Now for this, of course, I don't. You can use your commons, and I want to draw dotted y equals. So this is like y equals x. Okay, so this is y equals x, and you have to reflect this over this line. How you do is you see what is this point. This point is tan 5. No, sorry, tan 6. But this is 6. So all you do is if this is from the belongs to f, then 6 tan will should be belong to the graph of inverse. So all you do is you check where is 6 tan. This is 6, and you go all the way. Yeah, that's the point reflection of it. So the reflection of this point is here, and this point is 1 and 5. So if there is a 1, 5 here, 1, 5, so there I have to mark 5, 1. So 5, 1 will be right here. And this is how the reflection will take the first part. And then on this one is minus 10. So it goes minus 10 and goes to minus 7. So minus 7. So if this is minus 10 and minus 7 is a point of f, then minus 7 and minus 10 will be point of inverse. So we'll have to, where is minus 7? So minus 7 will be right here. This is minus 7. And minus 10 is right here. So I go all the way. That's the point. And now you have to join this. There you go. This is how, and clearly you can see the pink color is the reflection of the red graph. I hope it makes sense to you.